So now let's go into the discussion of tests of hypotheses for a population proportion. So our sampling distributions for a proportion is going to be based on a sample size n from a population with a true proportion, and we're going to say that it's nearly normal when we meet two criteria. One is that the sample's observations are independent of each other and that we've met the success failure condition. So the success failure condition is that we have a minimum of 10 successes and 10 failures. And so when both of those conditions are met, we're able to say that the standard error is going to be the square root of p times 1 minus p divided by n. So in order to apply this framework within the context of the hypothesis test for proportion, we have to make sure that those two conditions are satisfied. And so we're going to test the null proportion by verifying that n p naught and n times 1 minus p naught are at least 10, where p naught represents that full value. And so when we're doing confidence intervals on proportions, if the Klopper-Pearson interval is going to be used when we don't have the success failure condition being met. So here are some examples of potential hypothesis testing situations. So to test, first take a random sample from the population, and then we will assume the binomial assumptions that we have discussed earlier have been met. So when we sample from a single population and the variable of interest has only two possible outcomes, we call this a test of proportion. So in the one test of hypothesis, one proportion formula, P is going to be our sample proportion, pi is our population proportion, and n is our sample size. So here we have a situation regarding the governor's reelection meeting the binomial conditions. This is considered a one-tailed test, specifically a left-tailed test. So the region of rejection is in the left tail. The level of significance is the likelihood of rejecting the null hypothesis when it is true. And so you can find the critical value for this by referring to a t-table. And you go to the column indicating the 0.05 significance level, and then you can go down that column to the row that has infinite degrees of freedom, where you get the value of 1.645. Therefore, the critical value for this example would be negative 1.645. And the survey revealed that 1,550 planned to vote for the incumbent governor, and the sample proportion is 0.775, which was found by taking 1550 divided by 2000. And so that allows for us to get the computed value of z being negative 2.80, and that would be less than the critical value. So therefore, the evidence does not support the claim that the incumbent governor will return to the governor's mansion for another 4 years.